everyone. The goal of this video is to help us solve circle problems, and these are usually working backwards from what you're used to. So if you're working on IXL, this is usually the hardest type of IXL that I would give you. But if you're working in the real world, this is the type of problem where you figured out, how big the clock needs to be, but now you have to build it. Or you have a chair, but now you need the legs to fit in the chair correctly. So it's very real world problems that we're working with here, but most of what we're going to be looking at today is going to be very mathy, and that's okay. It's going to help us do some real world problems later. You're also going to hear me say the word equation a lot. And what an equation is, if you haven't worked with them before, is simply something where you don't know what you're looking for. So if you don't know the radius of a circle and you're looking for the radius, then that's an equation. And the variable you're trying to solve for is the radius. So these are just equations that involve circles. Okay? So when we are working on problems with circles, usually they're going to give us the radius or the diameter. So for example, if we have a problem that gives us the radius as 3 centimeters, we can then use that to find the diameter of 6 centimeters because the radius is half of the diameter. Okay? Then, once we have the radius, we can then use that to help us find the area. And the formula for area is radius times pi. So if I did 3 times pi, and like I talked about in the last video, I try to use the pi button as much as possible, 3 times pi. I end up getting something that is about 28 and 27/100 centimeters squared because we're dealing with area. Then circumference is diameter times pi. Our diameter is 6. So we simply do 6 times pi, once again on a calculator. And we get a crazy decimal again, of course, because we're using the number pi. And we get 18 and 85/100, and this time regular centimeters because it's a one-dimensional measurement instead of 2. And most problems work in this order. They'll give you either the radius or the diameter, and then you use that information to find the area and find the circumference. But what happens if you're given a problem where it gives you the area instead and you have to work backwards? Okay? So for this problem, it gave us the area. And we know that the area is equal to some number radius times the number again times the number pi. And all we do to solve this equation is we are going to guess and check to try to find the answer. As a big hint, I want you to use the decimal approximation as 3 14/100 for these types of problems, okay? So, to figure out the radius, all I'm going to do is I'm going to guess and check a radius and see if it works. So I can pick any number, but I know that most of the time the radius is going to be a whole number in math class. So I'm going to pick, what if the radius is 2? Let's see what happens. So I'm going to do 2 times pi, which I'm going to use the decimal estimation for these problems. And I get 12 and 56/100 inches squared, which means 2 did not work. So now I'm just going to try a new number. So let's try 3. I better label it this time. So now I just do 3 times my decimal approximation for pi. And if I type in 3 times pi, I get about 28 and 26/100 inches squared. Which, look at that, I actually got it right on the second try, which means our radius must be 3. from here, I can now solve this problem just like I always have. So if the radius is 3, that means the diameter must be 6, because the diameter is twice the size of the radius. Then I normally find the area next, but I already have the area because this problem gave it to me. So now I use the diameter to find the circumference, which is diameter times pi. And all I do here is I take 6 times pi. And now this time I'm going to still use the decimal approximation. And I get 18 and 84/100 inches. And now both of these again are about. So even though I'm using the decimal approximation, that what I type into the calculator will be nice and clean, it still is about, because they're never going to be exact when you're using pi. But as a recap, normally we start with the radius and diameter and work our way down. But if we're given the area or the circumference first, we use that to guess and check our radius or our diameter, and then we solve the problem from there. Let's do one more example, okay? This time, it gave us the circumference, and we know that the circumference is equal to diameter times pi. And once again, we're going to use the decimal approximation for pi for this problem, okay? So I am going to guess and check just like I did with the last problem, and I'm going to pick a number. And this time, I'm going to do 3. I'm going to guess the diameter is 3. Okay? If the diameter is 3, I do 3 times pi, which is the decimal 3 14/100, and I get 9 42/100 centimeters, which is not correct, so that means the diameter cannot be 3. So let's try 4. I do 4 times pi, and when I type that into a calculator, I get about 12 56/100 centimeters, which is also not correct. But we're getting close. So let's try 5. Let's try if the diameter is 5. I do 5 times pi, and lo and behold, I get 15 7/10 centimeters. So that means the diameter must be 5, or very close to 5 centimeters. And so if I'm walking by your computer and I don't see this happening, I know that you're not writing down your guesses the way that you're supposed to be. If I see you writing down these guesses, I would love to help you, okay? And if you give me a couple guesses, I can always give you another hint. So if our diameter is 5, that means our radius is 2.5 centimeters. And now we just have to do the area, which is radius times pi, which is 2.5 times 2.5 times pi, which is going to give us kind of a crazy decimal, but that is just fine. And it spits out about 19 625 thousandths. And this is going to be centimeters squared. So we now have all 4 answers. Once again, we see what we're given with. We use guess and check to try to solve the equation. And we use that to solve the rest of the problems. As always, if you have any questions, please let me know.